In today's lesson, we are going to be discussing about network access control. Uh, so, in last week we briefly touched upon various things that we would be interested in when we are thinking about network security. And one of the areas that we will be discussing today is network access control, which would be one of the tools that we could use when we are trying to secure our network. So it is one of the tools that we use for that particular purpose. So when we think about network security, we always come back to this concept of castle of defenses. So what we essentially mean by that is it would not be sufficient for us to have a single form of defense when we think about network security. So it is similar to how we would think about securing a traditional environment, like say a castle, for example. So if we think about a castle, like a fort, and if we want to protect that, we don't have a single mechanism to protect that. We will have a number of different security measures made in that environment so that we can continuously protect that environment, even if one of the protection mechanisms fail. So what we essentially have there is, say, um, we can have like a number of layers of walls, and then we can. So likewise, we can keep on adding different layers of security. So this is where we come back to the concept of layered security. So instead of thinking of it as a single layer or single level that is going to protect us, we will have a number of layered approaches. And the advantages of doing like that in a layered approach is, say, if one of the layers fail, say, for example, if we have an outside perimeter layer that we are using, and if that outside perimeter layer fails, we would still have something that would be inside that can protect us. So the inside layer is to protect us. So again, in each of those, we may add more and more additional layers. So that's a very basic way of thinking of uh, securing a network as well, because what we would essentially think is our network is in the middle, so that is what we need to protect. And anyone who is able to break one of these layers will have to pass through a number of other layers, get into our network. So that is the way that we will think about network security. So an analogy to think about network security. So if we bring that back to network terms, network terminologies, we can think of these sort of examples. So if we are connected to the internet from the outside world, we can have like a number of firewalls set up at different points. And so each of the firewalls can act like some protection walls in the physical world example. And then we may have certain areas that as demilitarized zones that would be separate from our main internal network. Then our internal network can be again behind another secure area, another firewall, and then again there we'll have a lot of internal systems. Then within our internal systems also we can have further even more higher critical systems behind another firewall. So we will have a number of things to break into before we reach the mission critical things. Say for example, if somebody needs to uh, connect to these mission critical systems from the outside wall, they will need to go through the outer perimeter firewall, then the firewall after demilitarized zone, then the internal firewall, and they reach or breach into the mission critical system. So that's how we will see this layered security playing out in our network secure network environment. And another thing to remember is that is when we talk about firewalls, for example, uh, we will be discussing about different aspects of firewalls later in this course as well, and also we will be you will be um, having some other additional discussion topics as part of advanced topics in networking. That module also will cover some aspects of security, network security topic areas. So some of some of those topics will also cover these so these aspects. So when we think about firewalls, uh, firewalls can be set up or like the concept or the basic idea of firewalls is like some mechanism that is going to block things from entering into a space. It is a mechanism to blocking things. So that type of blocking mechanism can be employed at different levels. Uh, and when we think about the OSI layers, we can think of firewalls being deployed at different layers of the OSI layer. So we can have things at the network layer where we can do packet filtering at network layer. We can have transport layer level securing. We can have application layer level securing, or we can have certain mechanisms that may be able to function across branches. So some firewalls may be operating at individual layers or firewall mechanisms, whereas others may function across layers and do a more thorough filtering, blocking mechanisms. So these are some of the possible ways these solutions can be built. Because when we are thinking about firewalls, we see them as part of the solution, part of the security mechanisms that we are going to employ. And when we think about how those mechanisms are going to be employed, they can be built at different levels or different OSI layers to do different things. But the underlying concept would be this blocking aspect of traffic, blocking something that is going to come in. So that would be the basic idea, but we can do it in different places. So then there's the question of what do we do with Trojan horses? So when we think about network security, uh, what is the problem with Trojan horses? Why do we see Trojan horses as a particular challenge in this environment? Uh, what is the significance of that? So the concept of Trojan horses is some threat that is going to hide behind something else and going to get into uh, the secure area that is going to breach security by way of hiding behind something or hiding inside something. So it's concealed within something else. So this is going to be a key challenge to detect when it comes to security, and it's a challenge in network security as well. So the problem here is if we are to detect Trojan horses, that is, things or the threats that are hidden inside something else, we will have to do further analysis, have further understanding of what is the nature of these threats and what is the nature of these connectivities. Are there any anomalies, any abnormalities in these connectivities? So we'll have to look at a lot of these things, and then we may be able to detect some of these things. So we are not going to go into specific discussions about Trojan horses or blocking Trojan horses, but the idea that you need to remember is these are threats that are not going to present themselves explicitly for you to detect in most detection mechanisms. So additional analysis, additional understanding of the overall network environment, the overall communication environment is established, and based on that, we would be able to detect any anomalies and block them uh, to potentially protect against any Trojan horses or similar type attacks. Okay, now let's think about network access control specifically. So we have established the framework of where we are coming from in terms of needing secure networks and what are some of the basic principles that we would employ, the layered approach to security and things like that. So one of those layers when we think about securing our networks would be network access control. So we will discuss that a little bit further today. So the reason why we need network access control is even when we have a lot of perimeter security, all our perimeter devices, firewalls, and all those things, uh, if we can secure them properly, we would still have a situation where some of our networking devices or some of the devices on the network can still be vulnerable or not secure. So, for example, if we take a university as an example, we can ensure we can work towards securing all the devices that belongs to the university, like all the firewalls, routers, network switches, wireless access points. So all these devices we can have, we can upgrade the firmwares, put security patches and all these things, and we can try to keep them as secure as possible. But we can't ensure the same thing with devices possibly from end users. Like if an end user is connecting from their laptop or mobile phone or anything like that, those devices are now part of the network and they can still be not secure. So they can be compromised, and through which certain malicious actors can get into the network. So the idea behind network access control is we will do checking before allowing networks to join a network. So that is, we will perform pre-admission checks when devices are connecting to the network. So when they are attached to the network, when the network connection is established, at that point we will perform this checks. And if a device fails such checks, then it will be denied access to the network, or potentially it could be quarantined into an area of guest devices or like separately, and they will have very limited access to other parts of the networks. And in addition to this aspect of checking and limiting who can join the network, we can also continue this post admission and do things like vulnerability scans, intrusion detection system, the detecting those detection aspects, behavior based, identity based. Likewise, we can continue to do a number of other security checks, monitoring, scanning things as long as these devices are attached to our network. So as long as these devices are part of our network, we can continue to monitor them and see if they behave as we expect. So that is the basic idea behind network access control. So if we summarize, we can see network access control as a common terminology that we will use to cover everything about managing access to the network. So it is about managing who can access our network, when they can access, and all the other aspects we can include with that. So what we will have to do is we'll have to authenticate users who are getting into the network. So identifying who they are, some form of authentication needs to happen. And then after the authentication, we can perform some form of access control. That is to determine what they can access, what they cannot access, what actions they can perform, and all that. So we will have some aspect of authentication and some aspect of access control also combined together as part of the overall network access control mechanism. And it can also include aspects of examining the devices. So all the other things that we mentioned, like scanning for vulnerabilities and all these other aspects, can also be part of a network access control mechanism. So within network access control, we will have we can sort of identify three main parts, so three main components that we will have to do. One is user authentication. So that is identifying the users, the authentication part. Then configuration assessment. So that would be the second part. And third one would be policy enforcement. So if we think about user authentication, here we can have number of different mechanisms for user authentication. So we can have layer 2 approaches when devices are connecting through switches or wireless access points. We can have layer 2 based user authentication mechanisms. If users are connecting through VPNs or such mechanisms, we can have additional layer 3 based user authentication mechanisms. So we can have different approaches based on how the network is structured and how the users are connecting to the network. Then with configuration assessment, this is where we can have measures like checking what type of software or other prerequisite things like antivirus scanners and things like that are part of the device that is attaching to the network. So this is checking for certain preferred configurations in those devices. So then we can do additional checks related to compare them with sort of network policies, and then we can reassess these things in a regular interval, like every few hours maybe, or every day, or like whatever the frequency that we desire. We may recheck these things on these devices that are attached to the network. And if there are certain devices that are not compliant to our requirements, the platforms that we require in a certain way, then we'll have to enforce certain security policies to limit what they can and cannot do when they are attached to our network. So this is where we will enforce our overall security policy on these devices. So this is sort of the 3 stages or 3 key aspects that we will have as part of our network access control. So with network access control, we can identify 3 main goals that we can have. One is identity and access management. So this is where we try to authenticate users, identify users, some form of attaching an identity to these devices that are connecting. So like if a laptop or a desktop is connecting to our network, we try to associate with a user rather than just based on the IP address. So if a particular laptop is connecting, we try to have a mechanism through which we can identify whether the laptop belongs to a particular user or not. Then policy enforcement is where we try to establish certain policies and make sure that these policies are followed and all the user access is according to the policy that we have them. And we can enforce these policies as part of our switches, routers, and other network peripherals like firewalls. So this is where these policies will be enforced. And the third main goal with network access control is preventing the mitigating the risk of non-zero day attacks. So this is not particularly suitable for zero-day attacks or minimizing zero-day attacks, but rather we are mainly focusing on these end station having the appropriate antivirus software, all the security patches are installed, all the other prevention mechanisms are in place. So this is mainly to ensure that the basic level of security that we require is in place across all the devices, and to minimize the risk of cross contamination. That is, if one device is compromised, the others are also going to be compromised. So to avoid that scenario, at least all the devices have a minimum level of security mechanism in place. So that is also another goal that we would have as part of network access control. So when we think about network access control, we can think about sort of three categories of components interacting with network access control systems. So we will have access requesters. So these are the clients or devices that are trying to access our network. So these are the any devices, workstations, laptops, mobile devices, servers, printers, all these things. Then we will have the policy server. So this is where all the policies related to who can access what and all these things, all the access policies will be as part of the policy server. And network access server would be the one that would function as the access control point. So this is where people who are connecting from remote locations would get through the network access server. So if you're connecting from a remote network, and in such scenarios, you may connect through this sort of a network access server. Essentially, this would be the gateway into our secure network. So, and then it would work with the policy server and additional authentication mechanisms and things like that as part of the overall framework. So if we think about how network access control is going to be utilized or used in a network environment, we can sort of see that through this example. So what we have here is we have some client devices or devices that want to connect into our network. Then we have our resources that we have as part of our network. Then we also have certain parts of the network that we would identify as the quarantine network. So the idea is any access request would come through the network access service. So any access request will come through network access servers, and based on the access determination, if they are authenticated or not, they may gain access to either the network resources, or sometimes they may be put into the quarantine network. So that would depend on the network access control and the final determination that is coming out of the network access control. So there we will decide where this network or these devices can go into. And so that is an overall sort of overarching look of how NACs would be implemented or would sit within the overall enterprise network environment. So now when we think about network access mechanisms, how we sort of enforce this access requests, there are a number of ways that we can, or number of places where we can do this part. So, like if we can do it at the level of say switches or access points, and we can use some standards or mechanisms such as A021X, something like that can be used at these devices, and they can limit access at that point. And there are a number of different implementations of these mechanisms. Different vendors will have certain different proprietary implementations or derivatives of common standards as part of the offering, like say Cisco or Aruba or Juniper. Like one of different people will have different mechanisms as well, in addition to sort of standard mechanism. Then we can implement these access again. VLANs can be another way of defining these access. So again, based on the users, we can determine different VLANs, and then people can only belong to different VLANs, and the access can be limited based on that. We can have firewalls. So firewalls can also perform this function where they enforce the action or the access requests. Another interesting place that we can use in this mix is DHCP. So when devices attach to the network and when they require to get information from DHCP, that could also be a point where some form of access enforcement can happen. So these are sort of different places where we can employ or where we can deploy access enforcement in our networks. So one of the main things that we would need as part of this access control is authentication. So we need to have some authentication method before we can actually go into doing access control, because we need to authenticate and know who the user is before we can enforce policies that are suitable for that user. So to do that, we need to know who the user is. So we need to do the authentication part first, and then only we can do the access control. So when we think about authentication, we have because we will have to have authentication at different points, because depending on how the network connectivity is established, what is the mechanism that we are having, the way that we are connecting into our network, we'll have to have different mechanisms or different places where we need to enforce authentication, where we need to have the authentication mechanism. So for that, we will have what is known as extensible authentication protocol, or EAP. So the idea is it is not a single mechanism but a framework that could provide network a suite of protocols to do network access and authentication. So it has so if we think from a layered point of view, what we have is we can have devices that are attaching to our network through different layers. So we can have so at our data link layer, there can be devices connecting to different mechanisms. It could be point-to-point connections or Ethernet connections, wireless LAN connections, or any other mechanisms can all be there as well. So in that context, what Extensible Authentication Protocol or EAP would do is, EAP would be essentially a framework. So it can have so it can bring in all these things together, and from that authentication protocol, finally it may be to each one can go through something like 8012X or something like that. But then after that, it can have number of different authentication mechanisms. Rather, it could support a number of different authentication methods on top of this. So that would be the overall framework. So depending on the organizational environment, requirements, needs, and things like that, different authentication facilities, different authentication mechanisms could be supported there. So when we think about such authentication methods, we can see like it could be transport layer security, tunnel transport layer security, generalized pre-shared keys, or like the idea is different organizations or different enterprise environments may have different necessities. They may have different underlying systems in their environment. They may have different existing systems that they may need to work as part of the overall authentication. Say, for example, when you need to authenticate into the network, you may also need to link up to the underlying user, some form of a user database or something like that of that organization. So that may live in a different system. So there need to be certain way of interconnecting these different systems. So that is where different authentication protocols come into play to support different aspects or different needs in different environments. So then when we think about how this authentication is going to functionally exist as a sort of mechanisms, we can look at the process of the components of EAP exchange. So what we have here is we will have what is known as the EAP peer. So that is the end device that is trying to connect to the network. And then we will have the authenticator layer or the device which we are going to get into. So that is the one that is going to be the authentication layer. And then behind the organization, it will have some underlying authentication server. Again, it can be a radius server or an LDAP server or something like that at the back. So the user or the peer device is essentially connecting to authenticator. Then authenticator is to the authentication server and figuring out the authentication, and as suitable, it will respond back to the peer or allow the peer, authenticate the peer based on the information from the authentication server. So the authenticator is essentially not doing, it's an intermediary connecting to the authentication server and the peer. So the requests are passed through authenticator, but the actual authentication happens at the authentication layer. So that is why we could potentially connect to a number of different authentication servers as well from the same authenticator. So this is essentially the flow of messages that we may have in such a environment. So how requests are sent and authentications are performed and things like that. So for example, what happens is, so if we briefly go through the steps here, initially you would try to connect to the network. So then the authenticator would go back and request for an identity. So once the identity is received or identity requested, the peer will send it to authenticator, which will forward to the authentication server. Then once the authentication server receives the ID, it will request some information to authenticate that. So that can depend on what is the mechanism. Then it will send that information, and it can have a number of exchanges of requests and responses. So authentication server can keep on asking for more information depending on the underlying mechanisms, and finally it will make a determination of whether it is authenticated or not, a success or a failure, and that information will be sent back to the peer. So that is essentially the basic way that we would authenticate a peer. So another common access control mechanism that you would come across in networks is what is known as the 802.1x access control. So this is commonly used when we are using Ethernet or wireless LAN or things like that. This is something that we can use there. So here what we have is we have a mechanism of authenticating or rather providing access control to devices that are attaching to the network, the client devices that are attaching to our network through a standard that is implemented as part of the IEEE suite of standards. So this is it's a common standard access control that we would come across, and quite often because it is one of the common standards we will come across. So what we essentially have in this one is if we are say we can have our network or the internet, and that would be connected to what is known as a controlled port. So if we are to reach to that network or internet, that part, it will have to go through what is known as a controlled port. We will have our authentication server attached through what is known as a controlled port. So if we are to if the say if the end device or the client or the peer, and it needs to access the network, it needs to be allowed, or it needs to be authenticated if it needs to access something that is attached to the control port. So if it is only authorized, it can access the control port or the information that is communicated through the control port. So that is to communicate to the network or the internet, whatever the secure network part. So that is the basic idea of 802.1x. So here we have a number of detailed terminologies and concepts that are associated with 802.1x. I'm not going to go into very much detailed discussion of each of these aspects. That is something that I would suggest that you go and refer and study that in detail. But these are some of the key components and things that we would come across. So, for example, supplicant or the end device is the device that is connecting to the network. Authenticator is the entity that is going to provide authentication. We will have an authentication server that can do that. Then we can have network access port. So there are a number of different concepts that we will have associated with this. So this is a common standard and something that you are more likely to come across. I would highly suggest that you refer to some of the materials. I will also post some additional materials on LMS. So I would highly suggest that you refer to those as well and get a better understanding of this. So when we think of network access control, one of the key issues that we will come across with network access control is the compatibility issue, because there are a number of open implementations, there are a number of standards, and there are a number of open standard implementations, and there are also a number of proprietary implementations. Say, for example, when we think of proprietary vendors, Cisco has their own one, Microsoft, Juniper, HP, everyone has their own implementation of some form of proprietary network access control solution. And many of these ones will not interoperate with each other. So then that has the other problems like having how we move from one network provider, one vendor to another, and number of those issues. There are a number of emerging standards. One interesting one is Trusted Network Connect from Trusted Computing Group, or TCG. But it is a fairly emerging standard, but it is becoming common in most, not most, but many devices. Many device vendors are also including this as part of their devices. Then there are a number of open implementations, and they may be present in certain devices. In certain places, they may be present as well. So that is one of the key challenges when it comes to network access control. That is compatibility between standards, and compatibility between the devices and what these devices support. So we will particularly look at Trusted Network Connect today, because it is a common standard and that is becoming much widely adopted recently, and it could become a more commonly accepted and more widely used standard in the future. That is the expectation. So we will look at that in a bit more detail today. So when we think about Trusted Network Connect, it is essentially an open architecture for network security. So that is, it is vendor neutral, so it is not particularly associated with any vendor like Cisco or HP or anyone like that. It's based on, or it sort of extends from the principles of trusted computing, um, and it is particularly its original focus was only about network access control, but now it has expanded to cover all aspects of network security. So it has a number of standards, open standards that are necessary for an overall network security implementation. So it has a full set of specifications, and it has been there around for like 15 years, more than 15 years now, and a number of vendors are part of it. So it is developed by Trusted Computing Group, in which a number of vendors, most of the larger vendors like Intel and Cisco and all these larger network related vendors are part of this. So most of the devices support this to some extent. In various ways, they have implemented these standards to various extents. So the Trusted Computing Group standards, it has a number of different, it covers all the different aspects of computing and sort of security in computing. So it covers from mobile devices to storage devices, servers, desktops, secure hardware, and all these things. And network security is one of those focus areas, or one of those uh, areas where number of standards have been developed by TCG. So one of the key components or key components that would be part of this implementation is what is known as a trusted platform module, or a TPM. So a TPM is essentially a secure hardware component where we can store keys, where like that is cryptographic keys. It is where we can store them and then utilize them for different aspects of authentication or storage or various purposes, because um, essentially that trusted platform module or anything that is stored inside is secured against any tampering or attacks. So that is the sort of idea behind it. So it can be used as a underlying mechanism for security. So then, given it has become fairly common across devices. Now it is possible to utilize them for various authentication and such approaches. And you may be familiar with hearing about this with the newer version of Windows, where they have made it sort of mandatory to have TPM version 2, I think, for you to upgrade to Windows 11 or something like that. So it has become such commonplace, at least in most modern devices that has come in the last few years. TPM is part of them, and you could use them as part of this security mechanism, overall security mechanism. So when we think about the security architecture of a standard network access control, um, this is how we would have the architecture in a standard network access control environment. So what we have is we will have the access request, and they will connect to the policy enforcement point, and we will have a policy point again. So this is what we have previously discussed. So request goes and respond and allow not. So that is the basic way that we structure this, the basic network access control architecture. With Trusted Network Connect, we have a number of additional components. So we have the policy enforcement, policy decision, and access request. So those components are still there. So those aspects are there. But in addition to that, we will have additional what are known as metadata access points and sensors and flow controllers. So the idea behind this is we are going to separate a number of activities between these different layers, and they together would come and provide the overall network security. Oh, that is the idea. So if we look at these other layers in a bit more detail, that is what happens at these layers. So here it is not just the access request and whether they are allowed to access or not. We will also have some additional things that we can utilize. We can use these metadata access points and sensors and flow controllers to determine how the network is being utilized, how a particular device attached to the network is using the network, how they are utilizing the connectivity, what they are doing with the connectivity. And with sort of a continuous monitoring and that type of an aspect, we can get a better understanding of the usage of a particular participant in the network. And with that knowledge, we can better improve our understanding of what happens in the network, and then go further and provide additional control. So if suddenly we detect a particular device attached to the network is doing abnormally large amount of network communication and things like that to endpoints that are not that it doesn't normally communicate or things like that, that information can be corroborated with these additional components that we have, and certain actions can be made based on that. So that is again a basic overview of TNC. So how it mainly differs from the traditional approaches is, in traditional approaches we have this sort of siloed approach. That is, we do say we take certain measures to network security, then we do certain other mechanisms to provide physical security, and then we do certain other mechanisms for our networking. So all these things are done separately with minimal interaction or interconnectivity between these approaches. But with this newer approach, what we have is we interconnect all these things together. So all the asset management things, all the physical security, that is physical security into spaces, like intrusion systems, firewalls, our network connectivity components, all these things are interconnected together, and we are able to provide a common access mechanism or common security mechanism in our networking environment. So finally, like why we sort of think of TNC particularly as a way forward is because it has become a standard that has been adopted by a number of providers over the period of time. So different people have implemented them on devices and software at the access requester level. Then there are a number of vendors have implemented them in their network devices at the policy enforcement level. Then number of vendors have implemented in policy decision points, like the authentication providers and things like that. Then there are meta access points and sensors and flow controllers. So it has had quite a lot of take up in the recent past. And as it is non-proprietary, we are able to choose across different vendors at different levels. Say, for example, our devices can have Microsoft operating systems, for example, that may connect to some network components on Cisco and some on HP and some IBM. And our backend can be from Junior, like that. We can have implementations that cut across different vendors. So that is basic idea of TNC, Trusted Network Connect. So with that, the main thing that you need to remember is with this module, we will cover a number of different topic areas, but it's more like we will be introducing these topic areas. We will cover some of the basics. But at this stage, the expectation is you are also doing your own self-study on your own reading and exploring the topic area and get a better understanding of these topic areas. I will share some additional resources on LMS that you can refer to, but beyond that, it is expected that you are doing those self-study aspects as well. So are there any questions on things that we discussed today? So if there are no questions, we may conclude our lesson for the day. Please refer to LMS for all the materials and other additional resources. And if you have any other question, please send them to me and we can discuss in the next lesson as well. So thank you for joining and see you next week. Bye.